Hey y'all, hope everybody's doing well. Alright, last time we talked about estimating trend with and without seasonality. And we used the additive decomposition model. We're still talking about time series, remember, so Y depends on T. Y, what's Y? Whatever you care about. Anything, something of interest. It's a variable. And we observe it over and over again for the same unit. It's your kid's height over time, or your business's revenue, or whatever. And it depends on time. It changes over time. It depends in a few ways. One is there's a trend, maybe. Another is there's a season within a year. There's periodic fluctuations. And another is irregular, which is just sort of noise. And then there's cyclical, and that's outside the realm of this class. That's a macroeconomic factor type stuff. But these are the three things we care about really: trend, season, and irregular. And so that's how it depends on time. That's what we're going to be dealing with. Last time we finished up talking about an additive decomposition model, which is to say that when we want to know where the heck t comes from, right? In any period, in any time t is a quarter or a year or a month or a day or whatever. T is a period of time. Where does that come from? Well, the additive decomposition model says, well, there's some trend effect that's going on, right? Some kind of overall gradual shift in one direction or another. It could be zero, but that's there. That gets added to a seasonal effect, right, which just pumps it up or drops it down depending on the season, which gets added to just the random noise of the world. That's the additive decomposition model, and that can be useful. Certainly, we have regression techniques that make that more useful. But in a lot of business-related applications, we often think that seasons lead to percentage changes. So we might have 10% more visitors in the summertime if we run a beach hotel or resort, or 50% or 100%. But we might think that that there's percentage changes rather than level changes. Part of this is because if you have a fixed customer base, if that customer base gets larger, then the fluctuations are going to be larger, right? Or might be larger, and so we might think that we would have percentage changes instead of level changes. In order to deal with this, the additive decomposition model doesn't handle that. So what we use is what's called a multiplicative. I know how to spell it. Writing it is tricky sometimes. Decomposition model. And what this says generally is that, well, our output for period t, that's going to be some trend effect, which is that's in levels. So that's the same kind of size as y, right? We think that's a linear trend maybe or something like that. But that's going to be multiplied by a seasonal percentage change. And that's going to be multiplied by a scaling error, right? And that makes sense a lot of times, right? Because if you sell a little bit, like if you're a small company and your sales are have some noise factor, it's going to be relatively small changes in levels, right? So you run a hot dog stand, well, you might sell 10 more or 10 less, or even 50 more or 50 less in the course of a day. But if you're Oscar Mayer, right, you might sell 50,000 more or 50,000 less in a quarter of a day. Your noise is it scales up with the size of the base. Okay. Now, if we want to estimate the trend, if we want to make good forecasts, and those are the two things that we're really doing in this class, trend estimation and forecasting. First of all, we are going to need to identify and isolate the seasonal impact, the seasonal effect. In addition, well, one other reason you might want to do this is that if you know that you have a multiplicative model and you know that your data is seasonal, deseasonalizing, which is kind of a word, smooths the data nicely. So that can be handy. Okay, now it's a multi-step process of deseasonalizing the data. That's what we're going to walk through now. But it's easy enough to do with a program like Excel. So I'm going to walk through the steps first, and then I'll show you how to do them in Excel. So we want to deseasonalize the data. But okay, step one. What is our seasonal period? This should be pretty easy. A lot of times it's quarters or months, depending on our data. Right? But sometimes, some places it'll be weekly, right? You'll have weekly data, and maybe, people come shop at the end of the month or right, at the beginning of the month, right when they get paid or something like that. Well, you need to account for that. If it's annual, if it's every 5 years and you have annual data, then you have a 5-period seasonal pattern. So this is 4 periods. This is 12 periods. It means that every 12 periods, the season flips over again, and that's what we're interested in. Okay, so we do that. That's good. Step 2. Well, if we're going to be doing forecasting, well, the next thing to do, certainly, is to develop a moving average forecast. And so what kind of moving average? Well, it's going to be this number of periods. So it's the number of periods from 1. Okay? Now, is it going to be... if you're smoothing, then you can use a centered moving average because you can take advantage of the fact that you know the future. And you can also do that to try to deseasonalize your existing data if you want to forecast in the rest. If you're forecasting, well, you may want to use just a regular moving average. We talked about that in a previous video, but what would this look like? Well, in the case of monthly data, if you have monthly data with annual trends, e.g., what you do then is you create a moving average, a 12-period moving average for month 13, and then each period after that to the end. What that does is it gets rid of the seasonal component. So this smooths out seasonal effects. Okay, so that's good. That's one of the things we want to do. Okay, step 3. Now what you do is you want to figure out in each month, for example, or each quarter, how does my current observation relate to the deseasonal, the moving average, the smoothed version. Okay, well, what we want to do, we can call this one up here. This is going to be ST. That's your smoothed observation. That's the moving average. What we're going to do now is we're going to find the ratio of each observation to the moving average forecast, right? So what does this look like? Well, let's call this ratio RT. Your ratio in period t is going to be your actual observed value divided by your moving average that you developed. We'll call this ratio to moving average. And what this tells you essentially is for any given period, how much more, what was the percent difference, or how many percent of the forecast was our observation, right? If it's greater than 1, it means that our in this current observation we had higher than expected. If it's lower than 1, then in that current observation we had lower than expected. Okay, now the next thing we do is we take all the similar periods, take all, what's a good way to say this? Find the average of the ratios for each month or season or periodic unit, right? So you want to find, so let's say we had R1 or R13 was January, and then R25 was January of the next year, and then R37 was January again. what we want to do is we want to take the average of R13, R25, and R37, right? Because basically what we're trying to do is we're trying to capture, like, well, what's the January effect? So the average here is our average sort of ratio, January ratio. Get an idea of just, what does January usually look like relative to the rest of the year? Is it bigger than 1? Is it less than 1? So if there are K periods, if there are K periods, you now have K moving averages, or not K moving averages, you now have K ratio averages. K average ratios. Okay, what are these? These are unadjusted seasonal indexes. There we go. That tells you, how your season relates to the rest of the year, right? To the average of the year. Okay, I'm going to need a little more space, so let me get myself a little more space down here. We're going to have to adjust these because what we want is we always want to be multiplying numbers by something that will end up so that we're not overweighting our data. We don't want to just inflate the series. So that's why this is called unadjusted, because now we need to adjust it. I'll change colors. I'm getting bored with that maroon. Here we go. So let's, this is that was step 4, right? Yeah, step 4. Step 5, let's adjust these. How does this work? Well, you divide each of the K ratios by the average of the K ratios. And what this does is it just guarantees that the average becomes 1. This sets the average index to 1, which is good. We want to, on average, be multiplying our numbers by 1. And so these are our adjusted seasonal indexes. Okay. Now we need to adjust the series. So we adjusted the ratios. Now we can, step 6, adjust the time series that we have. What do we do here? Well, for each observation, we divide. Let's call each of these, what do you call this? Yeah, I'll call it the adjusted seasonal index. We divide the observation by its adjusted seasonal index. Whoa, did I lose my pen? I did lose my pen. Okay. See if that's totally true. Nope, there we go. By its adjusted seasonal index. Okay, so what does that look like? Well, this means we're going to have a new smooth. Let's call it S sub t prime, which is going to be y sub t divided by the index for season of t. And this gives us our seasonally adjusted series. And this is good. This is a deseasonalized series. What is this? What have we done? Well, we had this multiplicative model. Remember, yt equals, it's the trend for the period times the seasonal effect times irregular. And what we effectively did was we got rid of this. We got rid of the season, right? We divided by season. We also averaged stuff out, which helped us get rid of some of the irregular. And this gives us our smoothed, which now is just going to be a function of trend with some irregularity still in there. We got rid of some of it, but not all of it. Okay. So what we now have, if we define, you can call it S of t or y squiggle, is yt divided by season t. That's what I'm going to use right now, actually. Y squiggle. And this is a deseasonalized time series. Just has some seasonal impacts removed from it. We can use this to estimate a trend now. How do we use this to estimate a trend? Well, what we do is we say, well, y squiggle t is going to be based on beta 0 plus beta 1 t plus epsilon. You estimate this and you get, well, our trend, which we'll call our trend for period t, is big T, little t. It's going to be b0 plus b1 t. And that allows us to do what's called a trend forecast. What's our trend forecast? Well, for period 23, it's going to be b0 plus b1 times 23. Okay, this only includes the trend though, right? Still, a trend forecast is very useful. What we've done essentially is we've taken a time series that was kind of a mess. Let's make it kind of a mess. Let's see. So we had a time series that was kind of a mess. We deseasonalized it, which allowed us to kind of flatten this a little bit so that we get a little fluctuation here. Right? Not a seasonal fluctuation, but just some regular fluctuation. And then we can use this to estimate a trend, which is just a straight line. And then we can forecast it out past that, right? And we just continue the line out, and that's what this is here. This allows us to make a forecast of the trend. What we want to do, if we want a good forecast, though, is we can seasonally adjust the forecast. How do we do that? Well, what we do is we have a predicted value of y. That's going to be our forecast. And it's going to be our trend for the period, t sub t, times the seasonal index. Right? We're plugging that season right back in. What does that look like? Well, we take our seasonal index, we multiply our trend, and that kicks out our seasonally adjusted forecast. Okay, so that's kind of abstract. It's a lot of steps. It works. Let me show you how it works, though. I'm pulling up some data from your book. There's a data set that your book comes up with. And it has data here on, I don't even remember what this is for. Pardon me. The book tells us what this, it's sales data from a bunch of different periods. Would like to know, but mostly I'm interested in deseasonalizing it and projecting it. We're not talking about causality. We just want to take a pattern and take a look at what it does. So the data already is separated out into periods. We have months and years. We can look at a time series plot if we want. We have 48 periods. A time series plot shows us that this is what it looks like. And this has a pretty clear seasonal impact, right? We have regular spikes and dips. And if we wanted to estimate a trend, we could just throw a line in there. It's an okay trend line. But I'm going to delete this for now. I'll show you another one in a little while. Okay, now let's deseasonalize. Well, what's our seasonal period? That's step one. Well, it looks like we have annual data, so we're going to have an annual seasonal period. Easy enough. So we have 12 periods, and that's what we're going to use. Now, in order to get a smoothed, to smooth this, we want a moving average forecast. So we want a moving average forecast for period 13. So let's create that. What am I gonna do? I'm gonna wrap the text here, and I'm gonna center all of this stuff. Sorry, no, that's not what I wanted to do. Okay, moving average forecast. How do we do that? Well, if you recall, the moving average for period 13, if we want to forecast, is going to be the average of the previous 12, since I'm doing a 12-unit forecast. So equals average of all of these, and that's my best guess for what 13 would be. I can copy and paste that all the way down. This will give me my moving average all the way through. Okay. So this is going up slowly but steadily, which leads me to believe that there's a trend. The next thing we have to do, that's step 2. We've created the moving averages. The next step is we want a ratio to moving average. So in each case, what we're going to want to do is figure out, well, compared to what we observed, compared to what we expected, what did we observe? So in each period now, we take our observation, we divide it by our forecast. September, clearly not a great month. Our sales were lower than we would have expected based on the moving average. October is a little better. November is above average. December is when it spikes. January is back down to an average, back down again in February. And I'm just copying these all the way down. You can see that whatever this business is, it doesn't do so great in the summer months. But come December, they spike. They must sell something that people buy in the holiday season. Okay, but now we have our ratio to moving average all the way through. You can zoom out so you can see this a little bit more in full, but then you can't actually read anything. Okay, so that's step 3. Step 4 is to find the average of ratios for each month. These are going to be our unadjusted seasonal, that's not a word, seasonal indexes. Okay, so we want the average for September. That's going to be the average of this one. Go down to the next September. We have that September. And I think we're going to have one more or two more. There's one right here. Do we have another September? We don't. We only have an August. So we have an average of 3 numbers here. And that's what we have, okay? That's our unadjusted seasonal index for September. Now, because of the way Excel works, if I just copy and paste this, that'll give me the average for October's, November's, December's, January's, February's, March's, all the way through until I get to August. And now I have my unadjusted seasonal indexes for every month, right? That's them right there. Now you can see down here the average of these is 1.02, which means that if we multiplied our data by this, on average we'd be inflating it by 2.5%. One of the reasons that's true is because we're using previous year sales to generate this stuff. And so our observation is on average going to be higher because it's bringing in the trend. So what we need to do is we need to adjust this index, and that will get rid of that effect. So we now have an adjusted seasonal index. What are our adjusted seasonal indexes? Well, if you recall, the easy way to do this is to divide this by the average of the group. Copy this down. Now you can see, wait a second, did that work? Oh, you got to divide it by the average of the full. You got to set this so that it's always divided by the average of the whole group. If you press F4 or put the dollar signs in by hand, it'll maintain what you're doing. And there you go. So, to walk back through, what I did so far is I created a moving average. I found the ratio of my observation to my moving average, 1.90 divided by 2.24, and so on all the way down. I took the average of my ratios to get my unadjusted seasonal index. I took my unadjusted seasonal indexes and divided them by their own average, divided each one by the average of the group to adjust it. And as you see, the average of these is 1, which is what we want. On average, we want to be multiplying our data by 1. Okay. So those are our adjusted seasonal indexes, and that is great. What do we do? Now we adjust the series. We're now going to have a seasonally adjusted series. How do we create one of these? Like so. For each observation, actually, here. This is what I'm going to do. I'm going to copy these over so that this is the September one. This is the October one all the way down. And then I have my adjusted seasonal index here. Again, all the way down. You can see that they're equal there. And it will just start over. So I'm going to get all the way to the bottom and just fill this down. And now it's just the same 12 numbers rolling over again and again and again. Every time their average is 1, there's 12 of them. But what I want to do now to seasonally adjust these is I want to divide the observation by its seasonal index value. Now if it's less than 1, what this does is it bumps it up, right? So what would September have been like if it wasn't such a dreary month for this company? well, it would have been 2.11 worth of sales, 2.12. What would October have looked like? We can do this all the way through, right? We're just adjusting everything. You can see that these big months, like 4.2, that gets bumped down to 2.46 because we've pulled out the December effect. Clearly, December has an effect, and we're pulling out the December effect, which is good. We fill these down, and now we have our seasonally adjusted series. Okay, now we want to estimate trend, and this is where we bust out our regression. So we have our seasonally adjusted series. We've managed to divide out the season effect, and now we're going to estimate trend. This is pretty straightforward. Go to Data Analysis in your Data tab. You choose Regression. Click OK. And our input is going to be our seasonally adjusted series. That's our input y. That's our dependent variable. And our x is going to be our period. We've included the label, so we want to make sure that's checked. And I'm going to name this deseasonal equals trend. That way I know that's what I've included. Click OK. And here we have it. Okay, what this says is that, well, if we want to estimate this trend, there's a line that goes through it. It's the intercept at 2, and the slope is 0.01 per period. And I can show you what that line looks like if you want to see it. What we've done is we've taken, I'll include the sales this time, and then I'll include the seasonal adjustment. Insert, scatter. And this is what we did. See, let me move this to a new chart, to a new sheet, so we can look at it larger. So we took this blue data, which was what we actually observed, and we got rid of the seasonal component. And this red series then gives us what the seasonally adjusted series was. Regression then gives us this trend line, which you can put the equation on there, and you can see it. Just get bigger. Yeah, not much though. Okay, and this is the trend line, so that's what the trend looks like. And that's the trend for the seasonally adjusted series. We could also look at the trend for the original series, and it's going to be pretty close. It's not identical, because there might be some seasonal noise that goes on in there. But this is the trend line that's more important. That's the one we wanted to forecast. This one right here, it's the one we're going to extend out to make our trend estimation because we have much more confidence in it. We've gotten rid of the seasonality. Okay, so let's take advantage of these, our intercept and our period, and we'll use that to put in our trend forecast. Let's say we want to estimate, let me go over here. Let's say we want to estimate sales for the next year. September, October, November, December, January, February, March, April, May, June, July, and August. Now this starts year 6, and we have these periods. Okay, and we're going to estimate those. We're going to use the trend forecast to estimate those. Now our trend forecast is going to be our intercept from our regression chart. That's this right here. And I want to press F4 to make this an absolute reference so that doesn't change. And then it's going to be, we're going to add to that our period effect. I'm going to press F4 again because I don't want that to change, times the period of the data, right? Period 1. So our trend forecast there looks like that. And we can just fill this down now. Because of our absolute positioning, this is just a line. That's all this is. It's just extending that line, and so you can see that it slowly but surely marches upward. We don't actually think the data is shaped like a line, right? We know that it bounces around, so we don't want to use this data. And I'll just show you quick what, if we throw this period in and the trend forecast and get a time series plot, it's just a line. Right? That's what we've done. It's just a line through the data. And we want to, but in order to make this a better forecast, what we want to do is we want to seasonally adjust the forecast. So how do we do that? Well, seasonally adjusted forecast. For these ones, it's just going to be smoothed, right? Because we didn't use these, but we take our trend and we multiply it by our seasonal index. Okay, so September's bad. It's a bad month for sales, so that drops that. we can use this forecast to check our forecast error using the methods that we looked at in a previous video with forecast error. But one of the really nice things is now we can make a prediction about the next year. So let's see what did I do wrong here? Oh, I didn't continue my seasonal indexes all the way down. If I do that, I'll be fine. There we go. Now we have our seasonally adjusted forecast and our seasonally adjusted indexes. What does this look like? Let's see. So we have actual sales. Let's look at our period, our sales, our trend forecast, and our seasonally adjusted forecast. Insert, scatter. Here we go. So this is what we see. Okay. So what we did was we used the observed sales data. We deseasonalized it. We used that to estimate a trend, which is this red line. And then we used our seasonal indexes and our trend to make forecasts for the next year. You can see that, the seasonally adjusted forecast looks a lot like what we have seen in previous years. And additionally, our seasonally adjusted forecast captures a lot of the variation that we actually saw. It's not a perfect fit because there's some error in there, but it's pretty good. And in particular, our forecast is going to be our best guess. This is especially if we have seasonal data with a clear trend. This approach does a really good job. Now the obvious thing is, well, December is going to be big, but yeah, in all, it gives us a pretty good bet of what we should expect to see in the next year. Okay, so that is how we use the multiplicative decomposition model to deseasonalize data. It's a kind of a lengthy process, but when you get there, you get some really useful information and really useful stuff that you can use because it's useful and you can use it. Anyway, I'm going to post a practice problem walkthrough that goes through a question where you're asked to fill in some of this stuff and work your way through it. So that'll be coming soon. In the meantime, if you have any questions, please send me an email at jjdelaney@ualr.edu or leave a comment, and I will be in touch as soon as I can. Thanks, guys. See you soon. Bye.